हेलो।
हाँ, गुड इवनिंग सर।
गुड इवनिंग। और खाना पीना हो गया?
जी सर।
डिनर हो गया क्या?
आपकी वॉइस नहीं आ रही सर।
हाँ, हेलो। अभी आया?
हाँ हाँ, बोलिए सर।
हेलो। सुनाई दिया? हेलो।
हेलो।
हाँ, सुनाई दिया? हेलो।
हाँ हाँ, आप सुनाइए।
हाँ हाँ हाँ। ओके।
अभी कैसी है तबीयत सर?
हाँ, ठीक है, अभी डिस्चार्ज होके आ गए। अभी ठीक है।
अच्छा।
वीकनेस तो रहेगा अभी। सबको हो गया डेंगू यहाँ पे।
हम्म।
ठीक है। तो स्क्रीन आपको दिख रहा है?
यस सर।
ओके, सो इंटरनल एग्जाम से पहले जो जो कोर्स आएगा एग्जाम में उसी को खत्म करना जरूरी है। तो
हम्म।
जो एनालिटिकल टेक्निक्स है इसमें इसमें दो चीज आएगा, एक तो यूवी विजिबल स्पेक्ट्रम एंड सेकंड एटॉमिक एब्जॉर्प्शन स्पेक्ट्रोस्कोपी और जो नॉर्मल स्पेक्ट्रोस्कोपी है। तो यूवी विजिबल हो गया था लास्ट क्लास में। आपने मटेरियल डाउनलोड किया था?
नहीं सर, अभी नहीं किया है।
हाँ हाँ, गूगल क्लासरूम कोड दिया था ना, उसी में होगा। तो
ठीक।
today we will see what is atomic absorption spectroscopy. As its name is absorption, that means it is working in the principle of absorption spectroscopy. Actually, spectroscopy is depend on the its mechanism into two types. That is, one is called emission spectroscopy, one is called absorption spectroscopy. So this particular atomic absorption spectroscopy, this is on the principle of absorption. How much this electromagnetic wave or electromagnetic radiation that can be absorbed by this sample, and with respect to the control, we just find out and see what is the concentration of the unknown compound. So this particularly this atomic radiation spectrometry, this is made only for heavy metal like or any metallic substances. So put in details what is the mechanism and what are the apparatus which is used in this atomic spectroscopy. uh, this spectroscopy is defined as the measurement of the intensity of light of the selected wavelength. Previously, we have already known in spectroscopy what happened for a particular substance. There is a different and unique wavelength of light we have to emitted from the source, and that light can be fall on the sample, and we have just see what is the absorbance or what is the maybe the emittance, and we should know by the detector what is the intensity of this source light and comparing with the source of light and the light which is absorbed or emitted. We can make the difference, and with the help of the detector we are know what is the unknown concentration. So spectroscopy is the measurement of intensity of light only basically, and through this intensity we able to know what is the unknown concentration when we are comparing with the standards and other library information. So this is mainly used only for quantitative and qualitative both analysis. For example, quantitative, that means we mostly use for the calculation of the unknown sample or unknown compound, unknown concentration. For qualitative, somehow some spectroscopy techniques are used for qualitative purposes only, because if mainly chemistry people, when the researchers we are mainly deals with the organic synthesis chemistry, they are unable to know what is the new compound form. So in order to know the new bond formation, the bond making, and what is the bond uh, uh, structure, what is the unknown structure of chemistry of the substances, that can be going to study with the help of spectrometry or spectroscopy or spectrophotometry, anyone anything we can just call it, all are same. So this spectrophotometry are different categories, mainly based on the two types, emission or absorption. But there are different types of spectrophotometry dealing with this instrumental design and mechanism. So visible spectrophotometry and ultraviolet spectrophotometry, both are we have already discussed, and both mechanism of the UV visible spectroscopy, that is previously visible spectrophotometer and UV ultraviolet photometer are different instrument. But when going for the new advancement, both UV and visible region spectrophotometry can be done with single instrument that is called UV and visible spectrophotometer, which can be dealing with both ranges, UV region ranges as well as this photo visible region. next Next region is called infrared photometer. Depending on the wavelength, what is the range, it can be called as infrared. For example, what is the range of UV photometer? UV photometer range is 200 to 400 nanometer, and visible range is 400 to 800 nanometer, and the infrared spectrophotometer range is 800 to 1500 nanometer. So these are accordingly what wavelength we have to use in this study of the unknown concentration. According to that, the instrument design is different, instrumental principles are different. Next is fluorescence photometer. Fluorescence photometer are also when the substances are active with to the towards the energy sources or light, and when it is glow, when for a photo or electron or photon can be fall into the energy absorbed into the non concentration or non sample, then the light can glow, then that is called fluorescence photometer. Some substances are there, it also use the technique that is fluorescence photometer. Then atomic absorption spectrometer and atomic emission spectrometer, both instruments are also widely used in case of detecting the unknown component, because this instrument of the measure technique or the principle of the all instruments are nearly mainly for the detecting the quality and quantity of the unknown sample. But when the for how some industry, for like if pharmaceutical industry, if the even a very small quantity of the chemicals, they are also very dangerous. So to know the very teeny amount of small quantity of concentration in the product, that we have to know, we have to use the sophisticated instrument, not generally we just use the UV visible gamma. So atomic absorption and atomic emission, these both spectrophotometer are very much sophisticated and can able to detect very tiny amount, that is ppb level of quantum concentration. Let's see, here in these slides we are mainly knowing where what is the introduction section, then invention, who is the inventor of this, and then what is the principle, then what are the different parts, the instrumentation and interference. So let's start one by one. The atomic radiation spectrophotometer is used to measure concentration by detecting absorption of electromagnetic radiation by the atom rather than the molecules. So the major difference between the UV visible and atomic radiation spectroscopy is it is able to detect the absorption of the light of the atom rather than molecules, because in UV visible region, UV visible spectroscopy, it is in the molecule range, but it is double AS, it is working in the principle of by the atomic absorption, not the molecular radiation. So it is very common technique to detecting metal and metalloids. If there is metal, heavy metals or metalloids are there, then we can must have to use this double AS technique. We cannot detect it in the UV visible range or IR range. So this is widely used in chemical laboratories to measure elements such as aluminum, copper, zinc, whenever they are necessary to measure the this metal, we have must there is a that double AS technique. See in the periodic table, this pink color is all of the metal. From the left side is soft metal, and the right side it is going to the hard metal or the heavy metal zone. So this metal or heavy metals or metalloids, somehow metal is present is there. So all these atoms are going to be detected by the double AS technique. So double AS is very much useful detecting any kind of metal. So this is invented by Alan Wallace in Australia 1955. This is the scientist who did firstly invented this atomic radiation spectroscopy technique. And the first commercial atomic radiation spectroscopy was introduced in 1959. And this is mainly used in case of mining and medical treatment or in agriculture sector. But now it is used everywhere for environmental analysis, pharmaceutical sector, agriculture sector, everywhere are going to use. The cost of this double AS also very much high as compared to the UV visual spectrometer. UV visual spectrometer cost is mainly 1 lakh, 2 lakh, you can purchase it. But double AS, there are instrument. Let us see what are the instrument. And according to the sophistication and the instrument, the cost is also high. That is minimum 10 lakh, 15 lakhs rupees. So the principle where obviously atomic absorption means the absorption of the atom or the absorption of the wavelength in case of atom, that is the we have to know, we have to measure. So this is the absorption of spectrophotometric technique, which metallic atom of the sample absorb light or a specific wavelength. All all metals have ability to absorb a very unique and specific wavelength. None other wavelength or that can be detected. Because for example, let sodium can absorb only 589 nanometer of wavelength. So specific the wavelength we have to choose 589 so that we can detect the sodium. So similarly for other elements or every individual atom or metal, we have to use a particular wavelength of light for detection of this particular wavelength. And this element is not appropriately excited in the flame, but merely dissociated from the chemical bonds and place of unexpected ground state of the atom. Here the technique main is previously what happened, directly the light is fall into the sample and we can observe the molecular radiation. But here we have to dissociate or break the chemical bond of the molecule, because atom mix with the molecule from molecule, and here we are giving such much of energy so that the atom if the molecule can be dispersed in the atom form, and the atom with metal atom that present in any form, that can be absorb the specific wavelength, and that we have to measure the this type of the excitation of energy that from absorbed from ground state to its excited state. So here a halo cathode lamp or the cathode lamp is used by the procedure called wavelength specific to the atom. We already said that for every atom there is a specific wavelength of light or lamp we can be used. For gold, that is a different light we have to use. For zinc we have to use different light. So every element having its unique properties of absorption, so we have to use different on light or source. So, for example, the sodium 589 nanometers should be emitted by the lamp. So, whenever we are going to use sodium, what is the concentration of sodium in the wastewater? Then we have to use the light that emit 589 nanometer of wavelength of light. So, this is fixed. Similarly, there is a fix for every all atoms. So, when the light from the hollow cathode lamp enters in the flame and absorbs the ground state, then it can be intensify and the molecules break, and what happens, the atom can be absorb the light. So this process is called atomic absorption. First molecules are break into atom, then the atomized molecules atomization, after atomization the particular intensity of nanometer of light that can be absorbed in the atomic state of the compound. So this is, that's why it is called atomic absorption, because you have to break the molecule to form an atom. Then concentration measurement usually determined from working cup or calibrating cup. That we have to first calibrate our sample or calibrate our instrument by measuring the known concentration. That is called or calibration of instrument. And this calibration graph we have to measure the unknown sample of the instrument. This is the instrumental part of the AAS. What are the instrument, major instrument that we have that are present in AAS? First, obvious, that is light source. Second is chopper, which can break the light. Third is atomizer. Obviously, we have to break the molecule and make the molecule in the atomic form. Then atomizer is must here. Then monochromator, which allows the light in particular specific wavelength. Then detector, after absorption, we have to detect the light. Then amplifier, because AAS technique is used for very small minute quantity of the atomic, minute quantity of the elements that can be, so we have to amplify the signal which have be comes out from the detector. Then is readout service device, or that is we have to printer or monitor or computer, we have to save the data. Let's see what are the different this is the schematic diagram of the spectrophotometer of the component. See, first is halo cathode lamp. See, this is the cathode lamp or light. Light can be emitted, or this light is based on the which element we are going to measure, or which element we are going to measure the concentration. For different atom or different elements, we have used different lights. Then chopper. See, what is the work of the chopper. Chopper breaks the light in a particular interval. This is the work of chopper. Then here it is the part of the element or atomizer. Here we are light or flame, we have to measure, insert in the light, and again there is an entrance slit where the light can be passed through. Then there is a monochromator, this particular wavelength of light can be passed. Then exit slit and detector. This is the simple graph or simple schematic instrument of the atomization spectroscopy. In this flame, what happened? In this flame, this is atomizer. So here we have to introduce our sample here below in the flame. So this is called atomizer. Let's see what is the different flame. So this is the flame and this is the cathode. Specifically this flame area is here, and this flame, there is a, we have to inject fuel and air, as well as there is a pump which can inject the sample or the direct to the flame, and in the high energy the sample can get atomized, and that sample along with this light, this can be moving towards the detector. So there are different types of uh, double AS, that is single beam atomic absorption spectrometer, and second is double beam atomic absorption spectrometer. See, single beam atomic absorption spectrometer, which allows single beam and double beam. There is a reference beam also there, similar to the UV visible spectrophotometer. In that case also, double beam we take a reference, and if there is a sample we can directly measure the or directly compare the difference between the reference and the sample. But single beam we have to take out the sample and again place the different sample. So here the reference is the main thing. So double beam double AS is the advanced version of the single beam double AS. Okay, so this is the instrument. uh, Here is the real instrument. This is the halo cathode and this is the atomizer. Actually, this is atomizer and this is pump. This is the pump where we have inject the sample along with this flame, and flame is here, and the halo cathode lamp is here. And while atomization, the sample it can be passed through this path, and this is detector, and we have to save in a monitor. This is the in atomizer there is different furnace are there. Let's see what are the different units of the double AS one by one. Light source consisting of halo cathode lamp and electrode discharge lamp. So either you can use halo cathode lamp or electrode discharge lamp, and this halo cathode lamp, and that is anode and cathode are there, and there is inert gas present here. When we are charging the electricity, this inert cathode that can be allowed different intensity of light then pass through this. This is the halo cathode lamp. This is a schematic diagram of halo cathode lamp. This is in the form of cylinder and made up of element being stored in the flame, filled with the inert gas, that neon or argon, and this is glass tube. For your special glass that allow transmission of the proper wavelength, use a window. This is the window which can be use this kind of halo. This is the majorly halo cathode lamp is used in double AS. And this how it works, particularly a potential difference is applied between anode and cathode to become the ionization of the atomic gas. Here there is a potential difference is allowed, and after the potential difference the inert gas can be charged and this light can be passed. This is not we're not going to details how cathode lamp is used. Then next is the electrode discharge lamp, and this consists of evaluated tube material of instead of प्लेस, मतलब जिस मेटेरियल का हम लोग चाहते हैं कि मतलब सोडियम का करना है तो सोडियम मेटल का यहाँ पे लैम्प यूज करेंगे, तो जिंक का करना है तो जिंक का यूज करेंगे. सो दिस इज the advanced version of halo cathode lamp, and this tube is filled with argon gas at low pressure and difficult to make a stable halo cathode lamp from the certain elements. Then this is the use. Not this electrode discharge lamp is not used for the all other elements, but specifically for the elements particular some arsenic and selenium, we can use this halo cathode lamp. Next part of this double AS is chopper. Chopper is nothing but a rotating wheel and interposed between the hollow cathode lamp. This is the chopper. That means a hollow disc. Some parts of these are hollow and some part of the disc that are packed. So this is moving. When this is moving, the light source can be break an interval of the light that can be passed. That is the main work of the chopper. And this interpose the break and steady light, because light is passing steady light. When there is breaks happen, then pulsing of light that can be passed. So this is the main work of the chopper, which means it pass the pulses light in a particular time interval, and this pulsing light gives a pulsing current in the photocell, because the photocell, after some picosecond or some nanosecond, the light can be fall simultaneously. So there is a steady current caused by the light that emitted flame, but this pulsing current is the recorded, because the light, this is the steady light, and pulsing light is this is the pulsing light. Or so this pulsing light is required in order to detect the atom. Next part is atomizer. Atomizer or atomization is the separation of particles into individual molecules. That means molecules are can get be separated and dissociate the bond, chemical bond to form the atom. So main work of the atomizer is breaking down the molecule to formation of the bond, atomic bond. Dissociation of the atomic bond and break down the molecule to form the atom. So atomizer converts the liquid sample into small droplet, and that can be easily vaporized. That means it is a sprinkler which can be easily form the liquid droplet into some droplet. Sprinkles the liquid into the flame along with the flame, and the droplet can be easily break the chemical bond and form a atomized vapor form. So there are different types of atomizer: flame atomizer and non-flame atomizer. Actually, there are flame atomizer is used because this is very low cost, and non-flame atomizer is high cost. So total consumption burner and premix burner. There are different parts of the flame atomizer. See, let's what are the see. The parts are, first is nobilization. That what the nobilization cost? It converts the liquid sample into final state. That means the atomizer is the assembly unit, and the nobilization is the one part which has the ability to sprinkle the water droplets. So water droplets is sprinkled. That work is done by the nobilization. Then desolvation. Solid atom are mixed with the gaseous fuel. Then next part is desolvation. When the water droplet is spring into the fuel along with the fuel, it is when it is burning, then the droplet of liquid form into gaseous stage, and this is called desolvation process. Then volatilization. The solid atoms converted to vapor in the flame, and this is called desolvation and devolatilization. So there are three types of particles that exist in the flames: atom, ion, and molecules. Because whenever the droplet that are sprinkled in the atom, so it can be formed either atom, ions, or molecule. So ions and molecule we are discarding, and the atomic atom parts of the molecule that are the our work, and it can be detect. So before the liquid sample enter the burner, it converted into small droplets, that is the work of nobilization. Then common method of nobilizer is use the gas moving into high velocity is called pneumatic nobilizer, because along with the in nobilization is like a just spray. The spray में जैसे होता है ना, वो spray करते हैं, तो that function is done by the nobilization. Then total consumption burner. This is one type of burner which can be atomize the flame, and this is called consumption burner, because whatever may be the liquid sample that we are using, total liquid sample that can be burned, and all atoms or consumptions of the all samples can be done. This is called total consumption burner, because in this type of burner, whole sample liquid sample can be burned out, and the liquid solution of fuel oxidation gases are passed separated passage and meet the opening of the flame. See here, this is the liquid sample, this is the air where it can be required for burning, and this is the fuel. So there are three passages, and which are open in the flame separately. This is called total consumption burner. One is passage for fuel, another is passage for oxygen or air, and another is passage for this sample. And these all are open in the flame simultaneously. So this is called total consumption burner. And premix burner, what happened? Here premix burner, to, before going to the burner, the fuel, oxygen, and the sample both are mixed, and the in a common line and open in the fuel. So this is called pre-mix burner, because before burning all these things are mixed. So what is the advantage and disadvantages? Because the pre-mix burner is non-turbulent, noiseless, and stable. And disadvantages is only 5% sample reaches the flame, and 90% is the wasted. Because whenever they mix, where main aim is to count the number of atom when the dissociate is from atom, molecule, and ion, all this form. So the atoms are the main component that can be absorb the light, and we have to detect the absorption capacity of the atom. So here 95% is wasted and only 5% get be reach the sample. So this is the disadvantage of premix burner. So we have mostly use this total consumption burner, because here mostly all total consumption can be takes place. See here, flame temperature of various gas. When there is a using of natural gases, the temperature gone up to 1900 centigrade. If you use oxygen and natural gases, that can be used 28 degree centigrade. And when the hydrogen and air, that up to 2100 degree centigrade. Similarly, oxyacetylene, that is oxygen acetylene, that can go up to 3150 degree centigrade. That means this is the highest temperature can be used by the oxyacetylene gas, that can be mostly welding and cutting, used in welding and cutting. That type of also, because not all the oil and all the mixture can be used for same components, but for different atoms or different elements, when there is a necessary and up to where the temperature can be rise, so we have to use this kind of various fuel and oxidant along according to our sample that can be analyzed. We have to choose the fuel as well as oxygen. This is the flame. When the flame is burning, this is the complete so the point flame, and this flame having four zone: preheating zone and primary reaction zone, internal zone reaction, and secondary zone reaction. This is called preheating zone, that is below the flame. Then this blue portion is called primary reaction zone. Above the blue portion is the internal zone, and above the flame is the called secondary reaction zone. So internal region is the hottest part. See, the blue region is the above the blue region. This is the hottest part above the this blue region. So when the sample are injected just here, then the maximum chance of the sample that can be atomized quickly. So oxidation of atoms occur in the secondary combustion zone, where atoms will be from the molecular oxide produced for the surrounding, and the oxidation of atom can be takes in here. So this is a different flame for different element. For potassium, we have to use this blue flame. For sodium, we have to use this type of flame. And the copper or cobalt, we have calcium, this type of flame. Copper, we have to use different type of flame. For this flame, we are choosing. We have to choose different kinds of fuel and as well as the oxidant. Up to there, we have to require the what kind of temperature we have to record. We have to use different type of fuel. Then flame double yes is having this mode of advantages, that is short analysis time is possible, good precision level, and easy to use, and this is cheap. That's why we have using this flame type of double yes rather than non-flame double yes. And mainly this is cheap because the cost is very much important, and we are doing good precision and short time of analysis, that is very much required. And what is the limitation? It has low sensitivity, and it have not a single range. It has the range of this is different for the different sample. Requires flammable gases, that oxygen along with the acetylene or all these gases are required. Fuel is required. Attached unattended operation is not possible, because you have to regularly monitor the flame. Must not contain excessive amount of diesel solid. So there is some limitations also for that. Then come to non-flame atomizer, that is called electrothermal atomizer. Here we should not, or we have not to use any kind of burning or flame, because the temperature we have to achieve by this thermal or electrothermal or by the electric current, and it can be go high as 3000 degrees centigrade. And the heated graphite furnace provide the thermal energy to the chemical bond. Here we have used the graphite thermal current or thermal heat energy electric current to break down the molecules or from the atomic form. So this kind of actually non-flame atomizer is not used widely, because it is high cost, and there is a limitation to use. So this AAS is very mostly used in all the cases. Graphite furnace techniques, that is not required. We have no, not going to in details. Then this is also not details, not required. Next part is, so this is the limitation of this technique, that is very slow, poor precision. This is not required, so we have to use double, what to use flame atomizer, flame double S. So flame double S will mostly used in all the cases. Next important part is the monochromator. Monochromator is next important part, and which is the very much vital role play for selecting a particular wavelength of light for the our study. So it is used to separate out all thousands of lines, and without a good monochromator, detection limit is not possible. So monochromator used to select a specific wavelength. This is the main use of monochromator, that can be observed by the sample. So it excluded other wavelength. Only single wavelength can be passed through the monochromator. So monochromator is again two types: diffraction grating and freezing. This is same as used in case of UV visible spectrophotometer. A prism monochromator may be used by the material glass or quartz, depending on our sensitivity. We have to use this monochromatometer. Next is called grating monochromator. Obviously, we are already studied in the UV visible spectrophotometry. Grating is the a glass which can be caught thousands lines of break in a single, or very small spots are present in the small surfaces, that is called diffraction grating or diffraction monochromatometer. Next part is called detector. The light should be detected by the detector, and after passing through this monochromatometer, and this is very much crucial part. And the detector is a photomultiplier tube, and the main function of the light is detect the absorption or detect the absorption of the light that can be possible by this atom. What the lights can be absorbed when it is going from ground state to excited state. So signal could be displayed in the readout in the further sector. So detector, there are different parts of the detector. One is called photomultiplier tubes, and the composed system made up of glass vacuum tube and photoelectrode or several diodes or anode. These are different photomultiplier tubes. We should not go in details about the photomultiplier tubes. This is not required. Then next is called photodiode. Nowadays, photomultiplier tubes are replaced by the photodiodes, and the photodiodes are fabricated with the different semiconductor material, that is silicon, gallium, arsenium, and indium. All these things, because this is advanced version of this photomultiplier tube. So these materials absorb light as specific characteristics of 250 nanometer to 1100 nanometer of silicon. So this is the measuring the light of magnitude of wavelength. This is having uh, advancement that it can be also measure a different series of light, but whenever it is required. And last part is readout device. That is the after detector, the signal is placed to the in the readout device or monitor to check the different absorption of the spectrum, and that can be print out the area under the graph, and we have to determine the concentration of the particular atom or particular metal. So operational, how it can be operation or can be takes place. First, a pulses hollow cathode lamp and then turn amplifier are incorporated into double A atomic resonance instrument. Then the power of hollow cathode lamp is used, because operating a double AS, that is not so simple. So we have to make a standard operational procedure, and one by one we have to start the instrument, and after that finally we have to incorporate this sample into the double AS. So this is the procedure when how we can be start the instrument, and when light leaves the flame, then you have to pulses. All the things are on. Then turn on the pump and turn on the lamp. After that, we have to pass through the pass through vaporize atom through the different lamps, and we have to change the lamp according to our requirement. All the things are done. Then first, we have to measure the known concentration of the element. After that, we have to make a unknown concentration. Let's say example, we have to make a for this is for blank, then 0.2, 0.4, 0.6, like that. We have to make different standard solution, and according to this, the absorption can be noted down, and we have to make a straight line graph. This is called calibration curve. Then introduce to a unknown concentration, and let's say this is the unknown concentration that can be placed here. So what is the reference absorption, then we have to measure the condition. This is the our required concentration. This is the required concentration. Like that, we have to measure the unknown concentration from the sample. The application is very much widely used to the AS that mainly used for clinical analysis and environmental analysis. So as we are environmental student, we are must have to know the operation practices, how this can be operate, and we have to see. And it is very much necessary to handle the AS technique, UV visible AS. This is because this is the instrument. Without you can knowledge, we cannot work anywhere. So you have must have to knowledge in details about this AAS, UV visual spectrometer, all these things. So monitoring environment, that is finding out the level of various elements in rivers, sea water, drinking water. That is what are the different sodium, potassium level, what are the different heavy metal level, arsenic level. We have to must use AAS. Without AAS, that cannot be techniques. For clinical analysis, the example for blood, urine test, we have to use this kind of AAS. Then for pharmaceutical sector, some pharmaceutical manufacturing also used to in this process a different catalysts are present in final product or not. What are the different that can be also determined by these pharmaceutical sectors. Then in many industry they have used different raw materials and for analysis of raw material quality, product quality, or the toxic elements are present in the out in the food industry or healthcare industry that is present or not. That can be, for example, in agricultural industry we are spraying different fertilizer and insecticide pesticides in the plants. So either these insecticide pesticides chemicals they can be transferred to the fruits or not. Then we have to analysis the different parts of the fruits and flowers and see that no, this much amount of toxins can be transferred. So we have to see the check the toxic components or toxic impurity for this different industries. And obviously mining because all ores are metals are coming from the ores. So the concentration of the metals in the ores that can be detected by this ore mining or geological survey. So how much metal can be extracted from the gold mine or ore, that can also be detected by this all this AAS. So trace element for food analysis, trace element for cosmetics, trace elements for hair, all the different in forensic science they have to be used for detecting very trace. Why this use trace element? Because it can be detect very low level of this substance can be detected in AAS that cannot be detected by other techniques. So this can be used up to ppm and ppb level. So if there are very trace elements are also there, we can detect in this AAS technique because it is working in the atomic level or atomic principle, atomic absorption principle. Last part is called interference. So interference is nothing but a disturbance. That is uh, the phenomenon where two waves are superimposed. That is called interference. Because there are whenever there are two lights are superimposed, that is called interference, and this interference decreases the intensity of the absorption because it working in a single light or single wavelength principle. Because for some cases that might be interference takes place. So in order we have to remove this interference in order to get high accuracy and precision of this output. So there are two types of interference: spectral interference, non-spectral interference. So spectral interference includes absorption of the other closely adjacent species. For example, the particular element that can absorb 501 nanometer and 502 nanometer for the same cases. So this small difference between 501 and 502 it cannot be determined by this machine. So here that interference can take place. We cannot know the exact intensity or cannot know the exact amount of the concentration. So when the two atoms are absorbed nearly or near a wavelength, that maybe interference takes place. Scattering and non violet salt particles also have interference, or peroxides, oxides, they have interference or spectral interference. Background emissions can be also, we have to remove from the background emission. That's why we are running a blank sample. And without this sample, we have to run one or two times. So we can minus this blank or minus the background interference. Absorption by the atomic species is usually not a problem because atomic they have easily atomized and easily absorb the light and can be good ground level to excited level. Then spectral interference. This is non-specific interference which can affect novelization by altering viscosity, surface tension, density. Because whenever there is spring, if the sample is highly viscous, that may be very much difficult to spraying in the nebulization. That also having a small kind of interference. And chemical interference, because they are more analytic dependent, because some chemicals are not easily atomized. Some particular chemicals are not easily atomized because they are forming a complex bond with the metal. So in this case, this is the mainly takes place. Solute solvation interference means solvation and solute that not easily volatile. If the molecule is not easily volatile, then also this kind of interference takes place. Dissociative interference, if the metal and complex is not easily dissociate or degree of dissociation is very high and it is very low, then easily the component is not easily atomized, then this type of interference also takes place. Ionization interference, this because the formation of ion. And next is excitation interference, because it is easily excited by the substance, that is excitation interference. And lastly, this is called background correction, because partly we have to run the blank without sample, and minus that it can be minus from the sample with the sample, that is called background correction. This is very much required because the air also or then fuel also having some small impurities in this present in this fuel, air, and in atmosphere also. So in order to remove this interference, that's called background correction is very much necessary. This is not required. This is not required. Okay. Then this is all about double air, that is atomic absorption spectrometry. Another type is called atomic emission spectrometry, that it is also called as flame photometry. And this flame photometry or atomic emission spectrophotometry, this can be used to determine the electrolyte. For example, some elements or some metals that are formed easily in ionic form. So the ionic form of the metals that can be determined by this atomic emission spectrometry. That's called flame, also called flame photometry. And this flame photometry is based on the intensity of light emitted the metal that will be used in the flame, because directly we have to the flame is used to atomize the spectrometer, and in place of adsorption, here emission is mainly detected by the emission spectrophotometry. This is not basic principle is the when matter light absorbs same wavelength of light and emit light. So the in place of this absorption of light, here the emission of light is important, and we have to the compare the emission of light. Then it can be mostly used for the ionic metal. This is the difference. The sample can be tested using the absorbance presence of the metal ion, because your ion is present. So if the ion metal is easily from metallic or ionic form, then this emitting mechanism is mostly required. Flame photometry is various fuel, mainly air, oxygen, oxygen. Similarly, the atomization or flame is required in order to break down the molecular form to atomic form. And this flame intensity of the light is directly proportional to the concentration of the element and proportionally constant. That means if the concentration of elements and concentration of on the impurities is more, then intensity light emitted is more. So in place of directly proportional that concentration, when the emitted light is can be measured, this kind of concentration can be measured. See, this is the different specific wavelength that can be used for the flame photometry. For barium, that is used 554 nanometer. That's sodium 598, 589, calcium 662, lithium 670. Actually, these all these are particular for this particular type of metal ion, because these are commonly present in ionic form or commonly converted to ionic form. So we have to use this kind of nanometer or this kind of wavelength, and this is the different flame color. When this kind of metal is present, if the sample is uh, put into the flame and there is yellow color is out, then we have to just know obviously sodium ion is present in this solution. If the flame is color is red, then we have to know that this is lithium ion is present or lithium is present. If the flame color is violet, we have to know the potassium ion is present. So this is the difference between atomic absorption spectrophotometry and atomic emission spectrophotometry, or it is called as flame photometry. Here it is atomic absorption is the main account. Then here you have to take account of the atomic emission. Here hollow cathode lamp is used as a source of light, Here, no hollow cathode lamp is necessary. Only the flame is used. Here, atoms are most of the ground state are able to absorb emitted light in the cathode lamp. Hence, here once atom is excited, it can be ground state and the specific wavelength light is emitted. Here, 100 times more sensitive than this atomic emission spectrophotometry. This is less sensitive. So, unique specificity wavelength can be used for different elements or different atom of different metal ion. So double S is having higher advantages than over this atomic addition spectrometry. So mainly double S is used in all the cases or all the laboratories, particularly in chemistry in lab or in industrial lab or mainly in environmental lab. We have
सर ये वही रीजन थोड़ी है।
क्या हुआ? Hello. You should go to all details. एक बार reading करना अच्छे से. And these are mainly important questions. What is the difference between double AS or what is the advantages of double AS? And what are the different instruments that can be used in double AS? What are the instruments that can be used that in UV visual spectrophotometer? All these things. So ये खत्म अभी इतना डबल एस में. तो एग्जाम में ये डबल एस तक आएगा. यूवी विजिबल स्पेक्ट्रोफोटोमीटर और डबल एस ये तीनों आएगा. ताकि वो डाउनलोड करके इसको रीडिंग करना है. आपका एग्जाम कब है? 21 को या 22 को है? 20 से स्टार्ट हो रहा है एग्जाम. इंटरनल एग्जाम के लिए आप आओगे? हेलो. हेलो.
सर यू आर नॉट ऑडिबल सर।
हाँ सुनाई दिया. हेलो. स्क्रीन तो दिख रहा है ना? हेलो. हेलो. नाउ इट इज ऑडिबल. हेलो. 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 हेलो सुनाई दे रहा है?
हेलो।
हाँ सुनाई दिया.
नहीं सर आपकी आवाज़ बिल्कुल नहीं आ रही सर।
अच्छा ठीक है. ये एटॉमिक रेडिएशन स्पेक्ट्रोमेट्री ज्यादा है नहीं तो उसमें थोड़ा देख लेना आप. ये एटॉमिक रेडिएशन स्पेक्ट्रोस्कोपी का जो मतलब क्या बोलते हैं इंस्ट्रूमेंटेशन पार्ट्स और यूवी विजिबल का इंस्ट्रूमेंटेशन पार्ट ये दोनों में एग्जाम में आएगा थोड़ा सा क्वेश्चन.
हेलो।
हेलो.
आपकी आवाज़ ही नहीं आ रही सर कब से। वही
अच्छा
बोल रहा
अभी सुनाई दिया? हेलो.
हूँ। हेलो।
सुनाई दिया अभी?
नहीं नहीं सर नहीं आ रही आवाज़ आपकी।
स्क्रीन दिख रहा है ना?
हाँ स्क्रीन दिख रहा है।
अच्छा नहीं मैं बोल रहा था ये स्पेक्ट्रोफोटोमेट्री जो है डबल एस एमिशन एब्जॉर्प्शन स्पेक्ट्रोमेट्री उसका जो मतलब मेनली इंस्ट्रूमेंटल पार्ट्स है उसका थोड़ा सा देखना है और उसका एडवांटेजेस बिकॉज व्हाट आर द एडवांटेजेस ऑफ द डबल एस टुवर्ड्स द फ्लेम फोटोमेट्री. इसका एडवांटेजेस क्या क्या है ये स्लाइड्स है एडवांटेजेस का इसका. हाँ एप्लीकेशंस में कौन कौन सा एप्लीकेशंस में आएगा. हेलो. इसको डाउनलोड कर लेना एक बार.
ठीक है कर लूँगा मैं।
हाँ हाँ, इसको एक बार पढ़ लेना, और कुछ नहीं हो तो फिर नेक्स्ट टाइम फिर बोलना कि कोई कोई स्लाइड समझ में नहीं आया तो।
ठीक है
हम्म।
सर। ओके सर।
हम्म।
ओके सर।
ओके, गुड नाइट।
हेलो।
हाँ हेलो।
हेलो।
हेलो। नेटवर्क गड़बड़ है। हाँ हेलो। हाँ, सुनाई सुनाई नहीं दे रहा था लास्ट में। अच्छा, वो नेटवर्क प्रॉब्लम हो सकता है। कोई बात नहीं, इसको एक बार पढ़ना। उसमें जो वर्किंग प्रिंसिपल है, उसके बाद क्या बोलते हैं, उसका जो इंस्ट्रूमेंटल पार्ट है, एक बार कंपेयर करना, जैसे कि वो यूवी विजिबल का क्या इंस्ट्रूमेंट है, इसका क्या इंस्ट्रूमेंट है, और दोनों का क्या प्रिंसिपल्स है। सिमिलरली है, जैसे कि लाइट सोर्स जो है वो सेम है दोनों में, तो डिफरेंट लाइट सोर्स चाहिए, उसके बाद डिटेक्टर्स भी सेम है। देन यहाँ पे एक एटोमाइजर जो है वो एक्स्ट्रा लगता है डबल एस में, उधर एटोमाइजर नहीं लगता है, फ्लेम नहीं लगता है। डायरेक्ट इट कैन बी यूज द इंटेंसिटी ऑफ लाइट, जैसे कि कोई पार्टिकुलर वेवलेंथ है, तो वो पार्टिकुलर वेवलेंथ में हम लोग उसको एज्योर करेंगे। देन यहाँ पे क्या लगता है, जैसे कि एटम को ही लिया जाता है, जैसे कि मॉलिक्यूलर फॉर्म टू यू हैव टू ब्रेक द बॉन्ड एंड यू हैव टू यूजिंग द एटॉमिक फॉर्म, दैट्स व्हाई इट इज कॉल्ड एटॉमिक एडजॉर्प्शन स्पेक्ट्रोमेट्री। वही डिफरेंस है लगभग। बाकी जो डायग्राम है, जो जैसे कि इसके बाद क्या क्या लगता है, एटम लाइट के बाद चॉपर लगता है, फिर एटोमाइजर लगता है, फिर उसके बाद क्या बोलते हैं उसको, स्लीड्स लगता है, फिर सैंपल होल्डर होता है, वो लगभग सेम है। हाँ हाँ हाँ। हाँ हाँ हाँ, ठीक है, उसको डाउनलोड कर लो तुरंत अभी, और थोड़ा देख लेना छुट्टी में। और अब एग्जाम देने आओगे इंटरनल? अच्छा, कोई बात नहीं, ठीक है, मैं तो गूगल फॉर्म में बना देंगे, तो उसी में कर लेना फिर। हम्म। ठीक है, गुड नाइट। है ना, है टेबल में ना, है ड्रेसिंग टेबल में, ये थी।